Lecture materials prepared by Vincent. Welcome back to our IoT lecture series. In Lecture 1, I explored the Internet of Things as a world of interconnected things, shifting from human-centric to machine-centric interactions. Today, I dive into the beating heart of IoT systems: data acquisition. This is how IoT devices sense the physical world and transform it into valuable insights. Imagine IoT as a ladder of knowledge. At the base is raw sensory data. Numbers, signals, and readings collected from the environment. Step up, and that data becomes structured information. Higher still, I find knowledge, patterns revealed through analysis. And at the very top, intelligence, decisions and actions taken automatically. Data acquisition is the critical first step that makes the rest possible. At the hardware level, two components rule the process: sensors, the eyes, ears, and other senses of IoT devices. These convert physical phenomena into electrical signals. Examples: cameras for visual data, EEG sensors for brain signals, and temperature sensors for climate readings. Embedded platforms or microcontrollers, the tiny brains of IoT devices. They are low-power processors with limited memory, yet capable of reading data, converting analog signals into digital form, and performing basic pre-processing before sending data on its way. Not all data is the same. Analog data is continuous, like a thermometer's gradual readings. It must pass through an analog-to-digital converter, or ADC, to be understood by a microcontroller. Digital data is discrete: on-off signals, counts, or states. These are simpler to handle. But here's the catch: IoT devices can't just send raw data all the time. Instead, they use edge processing, filtering out irrelevant information and detecting important events locally. This reduces bandwidth use, saves power, and speeds up decision-making. Once data is prepared, it needs to get to the cloud or a central system. And here's where wireless technologies shine. There's no one-size-fits-all protocol. The choice depends on range, power needs, and application. Short-range Bluetooth Low Energy, BLE, or Zigbee for device-to-gateway communication. Long-range LoRa for low-power, wide-area communication, and cellular networks for large-scale coverage. A gateway acts as a translator, bridging low-power devices to the broader internet, converting protocols, and ensuring interoperability between different systems. So, data acquisition in IoT is more than just sensing. It's an entire process, from detecting environmental changes, to converting signals, to pre-processing data locally, and finally transmitting it securely. Without it, the IoT would be deaf, blind, and mute. In our next session, I'll explore how the cloud processes this data to create actionable insights. Keep exploring, keep connecting, and remember, in IoT, the smallest sensor can spark the biggest change.